All right. Number 1, it says solve the equation, and I want to solve it for B. So in order to solve it for B, what do I have to do? What y'all do? Okay, good. First, I would highlight my B. So highlight it, bam. And then we're just going to get B by itself. So if I add D, I'm going to have A plus D equals B times 1 minus C. It would not benefit us to distribute, because if we were distributing, then we're going backwards because we just want B by itself. So if you leave it alone, you can divide this whole term by 1 minus C. And that is what B equals, A plus D over 1 minus C. Okay, if you did distribute, you're not going to get the correct answer because you would have B1 minus BC. You would have to factor, but we don't know how to factor yet to get B by itself, because you can't separate the C and you can't separate the 1 after it's multiplied to B unless you factor, which we'll get to later on in January. Okay, number 2, use the ideal gas law to answer the question, blah, blah, blah. Now, for this problem right here, they're trying to make it look more confusing than what it is. In fact, number 2 works just like number 1. Y'all got it? So, I want to solve it. Part A says solve for T. So, if I highlight T, how is that little n and that big R attached to T? Through what operation? And what's the opposite of multiplication? So, I'm going to divide both sides by n over r. So, my final answer is T equals PV over n big R. Part B says rewrite the gas law to show the change in volume. So instead of solving for T, guess what I'm going to solve this time? V. So what do I do to get V by itself? Divide by P. So even though they say to show the change in volume as the pressure changes, that's probably what threw you off. They just wanted you to solve for volume. That's what it means. So V equals N RT over big P. Raise your hand if you got that right. Awesome. Okay, number 3 is going to be super simple. The growth of Trevor's lawn can be modeled by the equation y equals 0.4x plus 7. What kind of equation is that? That is a slope-intercept form. Good job. This is my slope, right? And this is my y-intercept, correct? Okay, where y is the height of grass in centimeters. So that means that your y-intercept is in centimeters. That's the height of the grass. You got it? And x is the number of days, this is number of days, since the lawn has been mowed. What is the meaning of the y-intercept in this equation? The y-intercept here means that the grass is what? What'd y'all say? Good. It's 7 centimeters high. Initially, because that's the initial value. So the initial height of the grass is 7 centimeters. Now, I know I didn't ask you this, but what does the 0.4 mean? That's your slope. That's the rate of change. That's how fast the grass is growing. So it's growing 0.4 centimeters per day. Y'all got that? Okay, number 4. The temperature, Y degrees in Fahrenheit, can be modeled using the equation during the first 6 hours of the storm. This part right here is just meant to kind of throw you off, where x represents the time in hours, okay? So once again, this is slope, intercept form. What is the temperature at the beginning of the storm? What'd y'all say? It would be 18, because what's our key word here? Beginning. Beginning means initial value. So 18 degrees Fahrenheit. What is the meaning of the slope? All right, so my slope, what is the slope doing first off? Is it increasing or decreasing? So I would say it's decreasing. Now, what is it decreasing? Is it decreasing 4 apples, 4 minutes? What's it decreasing? 4 degrees Fahrenheit per what? Now, per hour. Now, where does this during the first 6 hours come in? This would come in if we said decreasing 4 degrees Fahrenheit per hour during the first 6 hours of the storm. That's just letting you know. After the first 6 hours, we don't know what happens. It might start decreasing 10 degrees per hour, or it might stay constant. So this part's just there to throw you off. Now, number 5, compare the y-intercepts of, we have an equation and we have a table. So to do the equation, to find a y-intercept, what do I make equal 0? X. You make x equal 0, correct? So in your calculator, and just in case you can't see it, I'm just going to write it up here. In your calculator, you should have put 0 minus 1. Did y'all get that? What'd you get as your final answer? Anybody? Anybody at all? Okay, well then I'll put it in the calculator for you. Negative 3 times 2.5 be negative 1.2. Okay, how am I going to figure out the y-intercept for the chart? It's where x is 0, but is x 0 anywhere here? No, so you got to do the pattern. You got it? So if I'm decreasing by 3, what's my next point going to be for x? 0. What's my next point going to be for my y? Because it decreases by 1. Good. So what's my y-intercept here? Now what's larger? Negative 1.2 or negative 1? So all you would say is p of x is larger than r of x. Raise your hand if you got that right. If not, that's a hard one. Don't get down on yourself if you didn't get a lot of these, because this is the first time you're really doing something like this. If it's March, then you need to get down on yourself and get serious. Okay. Let's look at number 6. Draw a line graph of the situation. A camper goes on a hike from its campsite and hikes for 2 hours at 3 miles per hour. What does 3 miles per hour mean? What's the word per indicate? Which means that is the slope. It's the slope. Okay, then he stops and rests for an hour. He walks back to the campsite at a speed of 2 miles. What does the PH mean? Per hour. So again, this is my first slope. This is my second slope. Y'all got that? And that's important to know. So if I was to draw a line graph, I'm going to start right here. Time is always your x. And what is our time in? Hours. So I'm going to do 1 hour, 2 hour, 3 hours, 4. I'm going to go all the way to 6. This is hours. Okay, and then this is how many miles, right? So for kicks and giggles, let's go up to 8. Okay. All right, where would you start? If you're starting the journey, where would he start at? What's his initial value? 0, 0, right? How many of you got that point right? Ooh, success. Okay, the next point, it says he leaves and he hikes for 2 hours. So I'm going all the way to 2, right? At 3 miles per hour. So how many miles does he hike the first hour? 3. How many miles does he hike the second hour total? 6. So just connect that. Then he stops and rests for an hour. What happens when you're resting? Yeah, it stays constant. It's a straight line. So, bam. And he walks back to the campsite at a speed of 2 miles per hour. So his first hour, for the 4th hour, he's going down 2 miles, right? So he's back at 4. Then the 5th hour, he's going to be back at 2. And then the 6th hour, he's going to be back at what? 0. He returns to the campsite. Ugh. Okay. But it should have looked something like that. Anybody get that right? Good. I'm going to be honest. If I was in 9th grade and I saw a problem like this, I would think, ugh. But it's not that bad once you look at it. Yeah, like friendship. Okay. Number 7. Number 7. Describe the meanings of y-intercept, x-intercept, and slope. There's no correct answer here. But y-intercept, that's just where, just your initial value. That's what I wanted you to say for y-intercept. I didn't want you to tell me how to find it. I wanted you to tell me what's the meaning. So I would say initial value. Okay? So y-intercept, initial value. For x-intercept, I wanted you to tell me that this is where, when someone returns. Because think about our hiker. The x-intercepts happen when they returned, right? Because it's where it intercepts the x-axis. So for a word problem, it's always where you're returning. When you're leaving or when you're returning. Got it? So returns or leaves. And slope is the rate. And we know it's rate of change. We know that. But it's the rate for the problem. Does that make sense? And you're either going to use the word increasing or decreasing for your slope. Okay? Now, number 8, I gave you a graph. I don't have it on here. But number 8 said, what is the domain and what is the range? And I think it looks like, right? And then it's a U. Is that correct? Knowing what we know now, what's it called? A parabola. Good job. Okay, so domain. It's where I start and stop. If you hold your pencil vertical, you can see that it starts at 3. And where does it stop at? Infinity. So remember, you can scratch out that. So that's our final answer. Or you can write it like this. Remember that? You just make sure it eats the same thing if you want to put x first. For range, what's the first thing you see from the bottom? Infinity. What's the last thing? So what does that mean it is? All real numbers. Okay, number 9 is a simple problem. It says, a function relates the perimeter of a regular hexagon to the length of its sides. What is the domain? Okay, this is process of elimination. First off, domain is what? X or Y? X. So automatically C and D are out. Got it? Okay, so between A and B, think about it. If I'm talking about the length of a side of something, will it ever equal 0 or will it be greater than 0? Has to be greater than 0, because if something has a side of 0, does it actually exist? No. So it should be B. I like that you said that. Okay. This is not the correct answer because I know why you said the domain has to be a line under it. Yes, when it's a graph like this. But it's not always going to be if it's not included in the domain. All the ones we've seen so far in Algebra 1, the pictures of the graph, those have been included. But in Algebra 2 and Advanced Math, you're going to start doing ones that don't have lines underneath it. Algebra 1, we just look at word problems that might not have a line underneath it. But do you understand why this word problem wouldn't have it? It's because a side can't be 0. If it's 0, the side does not exist. Therefore, it's not a hexagon. It'd be a quadrilateral. Got it? Okay, next. Number 10, a farmer writes a function, e of h, can be used to predict the number of eggs that will be laid daily by 1,000 chickens when exposed to h hours of light per day. What is the domain? What did I tell you was always domain? Time. So since time is always domain, I'm talking about hours of light. How many hours of light do we have in a day? Well, we don't have 24 hours of light. We have about 12, right? So I'm just going to say, what's the domain? It would be 1 to 12 hours. Okay, number 11. What is the average rate of change for the function for the interval 0.5 to 0.6 for the function f of x equals x squared? To find the slope, you need 2 points and then subtract your y's over your x's. So my first point is my first interval. My second point is going to be my second interval. You got it? Yeah. So x squared, if I put 0.5 into this, I get 0.25. If I put 0.6 into this, 0.36. And then all you do is subtract your y's over your x's. Does it matter which order you go in? No, as long as you keep the same order. So this is what I would have wrote. Who did this? Raise your hand if you did this. And Logan, what'd you get as your final answer? 1 point what? Okay, I'm just going to agree with you. Okay, number 12, we're going to do the same thing. But this time, notice how they wrote the same type of problem. What is the average rate of change between x equals 1/2 and x equals 1? So once again, I'm going to do my first point at 1/2, and I'm going to do my second point at 1. Does that make sense? Now, what do I do with that 1/2? You plug it into x. You substitute it. If it's hard to put in your calculator, you can just do 0.5. So if you put that in, you should get, I'm going to do it in my calculator real quick, negative 0.5 times 0.5 squared plus 2 times 0.5. So I get a really fun number, which is a decimal, 0.99875. Is that what y'all got? What'd you get, Logan, when you plugged it in? Okay. Okay. And then for 1, when you plug it in, that should just be negative 1/2 plus 2, which is 1.5, right? And then what do you just do? Subtract your y's over your x's. And the top, after you subtract, the top should be 0.50125 over 1/2 minus 1 would be negative 1/2 or negative 0.5. And we get 1.0025. What y'all get for y'all's answers? Okay, somebody got negative 15. What else did somebody get? Did you get a whole number? Okay. I'm going to check again. I'm going to check again to see if I put number 12 in right, but let's finish the rest of this just to make sure. But do y'all understand at least the process for doing it? All you're doing is you take this and you plug it into here. Then you take this one, you plug it into here, and then subtract your 2 points. You got to plug it into both. Okay, number 13. If negative 7, and there's no reason anybody should have missed 13 and 14, because we even did one like this as a warm-up. If negative 7 is a solution of the function f of z equals 1, what is the point on the graph of f of z? Yes. Yes. It should be negative 7, 1. That's, yeah, wait. It should be negative 7, 1. Because whatever's after the equal sign is your y, and what's in parentheses is your x. So what should this one be then? Negative 312. Good job. Whatever's in the parentheses, your x. Whatever's after the equal sign is your y. Here we didn't have anything in our parentheses, so just know that that would have to be your x. Okay, which is a function? To make something to be a function, what happens? What cannot repeat? Right, it's never fun to date your x's twice. So was this a function? Yes. Is this one a function? No. All right, 16 and 17 are very simple. It says if f of b equals 6b minus 2, blah, 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 what is the total cost for 10 books? What do you do with that 10? You just plug it in. That's it. So what's 6 times 10? Minus 2. So 58 is our answer. 58 books. Oh, wait. What is the total cost? So $58. Okay, what do I do again for this? If t equals 3, what do I just do? You plug in t. Now, you would need to do this in your calculator. And you should get 578.8125. We'll check how to do that in your calculator tomorrow. That's good. All right, moving on. Y'all good? Number 18, what do I do for the negative 1? Plug it in. But look, you see how there's a negative right here? That really means negative 1 times x cubed. Y'all got that? No, that doesn't cancel out. What this means is negative 1 times whatever x cubed is. So when I go to plug it in, you would have negative 1 times negative 1 to the third plus 2 times negative 1 squared plus 5 times negative 1. And your answer should be negative 2. Anybody get that? So you plugged it in wrong. We'll practice that one tomorrow on the computer too. All right, number 19, a botanist. Come Okay, number 19 says a botanist is studying the growth of a species of a plant. She writes a function describing the growth of the plant, where y is the age of the plant in years and dy is the diameter of the plant stem in centimeters. Describe the meaning of d of 4 equals 10. So it says where y is the age of the plant in years, and d of y is the diameter of the plant stem in centimeters. Now, d of y is just another way that we can write x, and y is just y. Remember, y is always after your equal sign. X is always what's in the parentheses. So this would be x, which would be the diameter of the plant stem in centimeters. And this is going to be the age of the plant in years. So your answer would be, at 10 years, the plant is 4 centimeters. 4 centimeters, yeah. You don't have to say high or wide. Okay, number 20. Nate buys a goldfish. The function f of m equals 2.5 plus 20 models the length of the goldfish in millimeters after m months. What is the meaning of 2.5 in this function? 2.5 is your slope. Okay, this is your initial value, 20. And this, since it's modeling the length of the goldfish, this is how much it's changing. And it's changing after m months. So you would say the goldfish, and since it's positive, that means it's increasing. So it's growing 2.5, and it is millimeters per month. And just to let you know, this 20, since it's the initial value, that means it's the initial height. So the goldfish started at 20 millimeters. Okay, number 21 just wants you to name one solution point for each graph. And a solution point is anything that is located either on the line or in the shaded region if it's an inequality. So any solution point for the circle would be any point that's on the line. So here, one solution point could be 3, 0. Or you could have said 0, -3. Or 0, -3. Or 0, 3. Or any of these points, but that'd be like a decimal. Another solution point here, I'm just going to do that one because that's easy to see. I'm going to say -4, 0, but you could have said any point located along the line. And then if it's an inequality, your solution points are anything that's in the shaded region. So I'm just going to pick this point right here, and that would be 3, 3. And that should be it for the EOC review.